Hello everyone, myself Twinkle from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. This video lecture is about wrangling the data. So what is data wrangling? Data wrangling involves processing the data in various formats like merging, grouping, concatenating, etc. for the purpose of analyzing or getting them ready to be used with the another set of data. So Python has built-in feature to apply these wrangling methods to the various dataset to achieve the analytical goal. So first of all, we will see understanding the classes in the scikit-learn. Then we will see defining application for data science using has function, considering the timing and performance using the preferred installer program, that is PEEP and conda, then running in parallel and on multiple cores. So first of all, understanding the classes in scikit-learn. Scikit-learn is the package for machine learning and data science experimentation. It contains a wide range of well-established learning algorithms, error functions, and testing procedures. There are four class types covering all the basis of machine learning functionalities, that is classifying, regression, grouping by cluster, and transforming the data. So, estimator is for fitting the parameters, learning them from data according to the algorithm. Predictor is for generating the prediction from the fitted parameters, and transformer is used for transforming the data, implementing the fitted parameters, and model is for reporting goodness of fit or other score measures. Now, defining the application for data science. So, we can apply the estimator interface to a classification problem, regression problem. So, classification means guessing that a new observation is from a certain group, and regression problem involves guessing the value of a new observation. For that, it works with the method fit x, y, where x is the bidimensional array of predictors, the set of observation to learn, and y is the target outcome, that is another array which is unidimensional. By applying fit, the information in x is related to y, so that knowing some new information with the same characteristic of x, it is possible to guess y correctly. Now we will see using the has function. So there are many hasing techniques such as MD5 and SHA. Python possesses a built-in has function and named has that you can use to compare the data object before storing them in the dictionaries. A scikit-learn has function can return an index in a specific positive range. You can obtain something similar using a built-in has by employing a standard division and its remainder. So this is the example of hash in Python. This time the resulting has is an integer number with the number 687. Next is has function is smarter way to handle the unpredictability in your inputs. So first we have to define a range for the has function outputs. All your feature vector will use that range. The next example will uses the range of value from 0 to 24. Next is compute an index for each word in your string using the has function. Next is assign a unit value to a vector's position according to the word index. So in Python, you can define a simple hasing trick by creating a function and checking the result using the toTest string. So this is the example of first uh, first first block show the example of the function hasing trick, and after that next two blocks shows the to string uh, to string applied on the hasing print function. So first string is Python for data science, and this is the feature vector for the Python for data science, and next string is Python for machine learning, and this is the output or the feature vector of the Python for machine learning. Now, considering the timing and performance, considering the speed, Jupyter offers an easy out-of-box solution, that is the line magic function, that is percentage time it, and the cell magic function, that is percentage time it. So, using the percentage time it, we can calculate the base performance time for an instruction, and percentage time it, which is a cell magic function which calculate the base time performance for all the instruction in a cell apart from the one placed on the same cell line as the cell magic, which could therefore be an initialization instructions. So this is the example of time it and percentage time it and percentage time it. So uh, Since the for loop requires an entire cell, so this is a cell function and this is a line function. The example uses the cell magic. Here the for loop requires the entire cell, therefore this example uses the percentage time it. Next, using the preferred installer program and the conda. Python provides a huge number of packages that you can install. Many of these packages come as a separate or downloadable modules. So, many other packages rely on the P, that is preferred installer program. The preferred installer program, which is a feature that you can access directly from the command line. To use pip, we can use the anaconda prompt. If you need to install the package from the scratch, such as numpy, then we have to type pip install numpy, and the software will download the package as well as the related packages that it needs to work and will install everything. We can also install a specific version by typing the pip install -u numpy is double double equal to 1.14.5, that is the version number, or simply update the package to its most recent version. If it is already installed, then pip install -u then numpy. Using the conda for installing a new package is also achieved from the anaconda prompt, as well as by entering the conda install numpy. The software analyzes your system, reports the changes, and then asks whether it should be proceed. We have to press yes if you want to proceed with the installation. You can also use conda to update the existing package by entering the system as a conda update dash all to update the system package, all the system packages. Now running in parallel on multiple cores. To perform the multi-core parallelism with Python, you integrate the scikit-learn package with the joblib package for time-consuming operations, such as replicating models for validating result or for looking for the best hyperparameters. In particular, scikit-learn allow multiprocessing when cross-validating or grid searching or multi-label predictions. Ensemble machine learning method. So in such multiprocessing processes, scikit-learn allows the multiprocessor or multi-parallel processing. So we can activate parallelism by setting the n_job parameter to a number of core more than one, or by setting the value to -1, which means you want to use all the available CPU instances. You start by loading a multi-class dataset, a complex machine learning algorithm such as SVC, that is support vector classifier, and a cross-validation procedure for estimating reliable resulting scores from all the procedures. The most important thing to know is that the procedure becomes quite large because the SVC produced 10 models, which it repeats 10 times each using the cross-validation for a total of 100 models. So this is the example of multi-core processor. So in this two example, we can see that the running on the multiple cores require a better average time, that is only require 941 milliseconds, whereas here it requires 5.28 seconds. Thank you.